Welcome everybody. I left a little bit early today, so I'm going to go over your homework and your lesson with you. So the answer to question number 1 for your homework is the price of oil. The reason why is the explanatory variable is the one that comes first, and it predicts the response variable. So first came oil, and we're trying to predict gas, so oil is explanatory. In question 2, as oil increases, gas increases, so there's a strong positive association. For question 3, I highlighted in yellow all of the Japanese cars. So the Japanese cars tend to weigh less, and as you can tell, they're all kind of to the left of 3, so that's why they tend to weigh less. And for question number 4, sorry, I'm trying to move this up for you. Okay. A correlation of 1 just means that it's a perfect relationship. So if every single time a woman marries a man 2 years older, then it's a perfect correlation, and it could always be predicted. All right. For question 5, if we have that point is far away from the other point, so it's going to decrease the correlation. Now, if we take that point away for question number 6, the correlation is still not super high, but it is better, so that's why I have 0.5 there as the answer for question 6. And your answer for question 7, I have the interpretations of the y-intercept, the slope, I have the line of best fit. For question D, 1,000 months is way past the data that we have, so we technically should not trust that. So that's called extrapolation. And then for E, I calculated my residual from my actual, my predicted. So because your predicted was slightly higher, we have a negative residual. The actual was lower. All right. So for question number 1 here, we have data, and we're going to go ahead and draw what's called a residual plot. I do want to just make note that there is an error for this lesson. So I have here the least squares regression line. I am going to change my y-intercept and my slope. So my y-intercept is 25.33 and my slope is 7.5. Okay? So just make note of that. So what we can tell here is that we have a looks like a strong positive linear relationship between number of rubber bands and the distance traveled. And if you go down here, we're going to calculate each residual for each of these points. So don't forget that your residual is the difference between the actual and the predicted. So for instance, if I wanted to predict what would happen at 0 rubber bands, I would plug 0 into my rubber bands here, and that would get me 25.333. So from there, I would then take the difference between my actual and my predicted, which would give me a residual of negative 0.3. So what we're actually showing now is if I look over here, we're saying that this point is super, super close to that line. Okay, you have a very, very small residual of negative 0.3. All right, so from here, let's go ahead and calculate the others. Let me just fix this here. Okay. All right, here we go. Sorry. I'm trying to get this to the best fit. Okay, here we go. So if we were to do 6 rubber bands, if I asked you what is the predicted distance travel, you would have to plug this into your least squares regression line. So if you did 25.33 plus 7.5 times 6, you would get a prediction of 70.4. Okay, now you want to ask yourself, how close were we? Well, if you take the difference between those, we were about negative 1.4 off. So our actual was slightly lower than our predicted. Okay, now what if we do 7 rubber bands? Well, let's see what we would have predicted. We would have predicted approximately 77.9. So were we close? Well, if you take the difference, we were off by just 0.1. So we were super, super close. So what you then do is you take all of these and you create a plot. So what you'll notice is that some of them are slightly above 0, some of them are slightly below 0. And that's what actually happens in a scatter plot, is that some of them are slightly below the line and some of them are slightly above the line. Okay, so what you'll notice is that you'll kind of have equal scatter. Some of them will be below, some of them will be above. And this creates a good model. We want that. We want equal scatter. So if you plot these, I have the first few done for you. So negative 0.3 is right there. Okay, so let's go ahead and plot negative 1.4. So it's 6 rubber bands. Negative 1.4 is going to be very, very low. And then for 7 rubber bands, 0.1 is going to be right here. So again, what you'll have is some of these points will be below, some of these points will be above. So what makes a good model? A good model has equal scatter and there's no pattern. So on the next page, you'll see what happens when you have a non-linear relationship. So here's your non-linear relationship, and if you look at the points don't look like a straight line. So if we were to create a scatter plot, you'll notice that there's a kind of a pattern here. You have a bunch that are below, then you have a bunch that are above, then you have a bunch that are below again. So this is an example of something that is non-linear. All right, so if we look at the multiple choice question here, it says the residual plots from 5 different least squared regression lines are shown below. Which of the plots provides the strongest evidence that its regression line is an appropriate model for the data and is consistent with the assumptions required for inference for regression? So pretty much we want to know which one would be appropriate for a regression line. Which one would be appropriate for a linear regression line? Well, I told you that we want equal scatter, no pattern. So which one has equal scatter and no pattern? Choice C. So there's our residual, and we have some below, some above, and there you have it. All right, the last page is really just going through a question. So I'll run through these with you, and then you are done for today. So 9th grade students at Webb Schools go on a backpacking trip each fall. Students are divided into hiking groups by size 8 by selecting names from a hat. Before leaving, the students and their backpacks are weighed. The data here are from the hiking group in a recent year. Below is a scatter plot that shows how backpack weights relates to body weight. All right, so one of the first things that I notice is that we have a bunch of points here. So body weight is going to be your explanatory variable, and backpack weight is going to be your response variable. And you can also see that down here. Body weight is on the x-axis, backpack weight is on the y-axis. So we're trying to predict backpack weight. All right, so if you put this into your calculator, you can create a least squares regression line. So the least squares regression line has an A that's 16.26 and a B that's 0.09. Now when you're writing the equation, even though it's set up like this, we want to know what is x and y. So don't put x and y. We want to put backpack weight with a hat over it, because that means prediction, is equal to 16.26 plus 0.09 times our x, which is our body weight. Okay, now from here, it says one of the hikers has a residual of 4 pounds. Interpret this value. So let's see what's going on here with our supposed hiker that has a residual of 4 pounds. If I look over here, do I see any hiker that's at 4 for a residual? We do. This backpacker. Okay, and if you look, our body weight is probably somewhere around here. Okay, so this is our prediction. This is what actually happened. So if this body weight was about 165 pounds, what we're saying is that when we tried to predict, we were a little bit off. We were a little bit lower than our actual weight. And how much off were we? We were off by about 4 pounds. And if I scroll over here, I can also see that. It looks to me like this point here, which is at about 35, is slightly off. That's at 31. So that's off by about 4 pounds. So what we can really just say is that our prediction was off by 4 pounds. And if we're a little bit more specific, our actual backpack weight was greater than our predicted backpack weight by approximately 4 pounds. So the actual backpack weight was greater or higher than the predicted by 4 pounds. Okay, and it kind of looks here, I can actually show you it. It looks like that actual point was at about 165, right? I can look at it. Let me show you. Right there. Okay, so that looks like that was our actual point. 165.35, but the prediction line looks like it hits at 31. So here you could tell that that's a difference of 4. All right, and then the last question is, based on the residual plot, is a linear model appropriate for this? Okay, the answer is yes, because there's equal scatter and no pattern. And I will tell you that this is probably not the best plot, only because we only have 8 points here. So you can kind of argue that there might be a pattern, but for now we're just going to say yes because there's equal scatter and no pattern. All right, let me know if you have any questions. Bye.